Hello, class. I hope everybody's doing well. My name is Jorge Olguin, and today I want to talk to you about tungsten carbide. First, what is tungsten carbide? Tungsten carbide is a metal alloy that do not occur naturally. It's technically produced by converting powdered tungsten metal with carbon black. Tungsten gets its name from a Swedish phrase that means heavy stones, after its heavy weight and strength. And a little bit of background. Juan José and Fausto de Luar purified tungsten in 1783, although Peter Wolf examined the mineral, which came to be known as wolframite, after he determined that it contained a new substance. The name wolframite is used in most European countries, and because of that name, its element symbol is W. In the early 1920s, a German electrical bulb company looked for substitutes to the costly demand diamond drawing dies. That led to the invention of tungsten carbide, and which was soon manufactured and marketed by a number of companies for several applications, where its wear resistance was especially crucial. Here are some chemical, physical, and thermal properties. The chemical symbol of tungsten carbide comes when combining tungsten W with carbon C, so we get WC. Its chemical composition is about 90%, 94% tungsten and 6% carbon. It has a molar mass of 195.6 grams per mole and is highly resistant to deformation, and it keeps its stability at both extreme cold and extreme hot temperatures. Its melting point is at 2870 degrees Celsius and its boiling point is at 6000 degrees Celsius. Now let's talk about the crystal structure. Tungsten carbide has a hexagonal form that can be visualized as made of a simple hexagonal lattice of metal atoms of layers long directly over one another, with carbon atoms filling the interstices, giving both tungsten and carbon a regular triagonal prismatic coordination. This structure is similar to the hexagonal closed pact that we learn in school. However, the ratio in tungsten carbide is about 98, 0.98, while typical HCP material is about 1.63. The process of tungsten carbide starts by combining the tungsten powder and carbon black. This process can be done in different ways. One of them is by a chemical reaction using extremely high temperatures. The WC powder forms in a crystal mass as it cools. Then the coarse WC powder is wet milled into a finer particle size depending on the product desired. During this step, soft wax lubricant is used to temporarily hold the particles together after compression. Then the wet slurry of powder is dry. After that, it comes the process of shaping it. Then the wax binder is thermally removed, allowing the permanent metal binder to melt and flow around the hard particles. Here's a little image about the process of obtaining WC. And now we're going to their applications. The applications of tungsten carbide can be found almost everywhere, from surgical instruments like scissors to sport usage, like trekking poles that are used for hikers for balance, and some car, bicycle, or motorcycle tires that take advantage of the traction that WC studs provide on ice. So these little things that you can see on the image of the tire, those are made of tungsten carbide. Other applications are machining, cutting machines, and that's the majority of the WC use is in these machines due to their high resistance. Also, tungsten carbide has become popular in the jewelry industry due to its highly resistance to scratch. WC rings require no maintenance, and its shine lasts for decades. Also, it's the most affordable. So this is a cutting machine tool, and over here we have a ring. Uh, that's actually my wedding ring. I took a picture of it. It's made of tungsten carbide. That's why I picked this material. Okay, well, thank you very much, class. And I hope everybody's doing well.